Hello, this video all about factors today. So first of all we'll look at what a factor is, and then we'll look at some common factors, and then something that's known as prime factorization, and then we'll look at some highest common factor stuff. So in that order, we'll start off with the relatively easiest part, which is basically what is a factor. So a factor is pretty much the opposite of a multiple. So basically what that means is a factor is a number that will divide into another number. So for instance, a factor of 6, well, we could say, well, what numbers divide into 6? Well, that would be 1, because that does. 2 divides into 6. 3 divides into 6, and also 6 divides into 6. Now we wouldn't be able to use 4 or 5 in this case because it doesn't divide fully, and what we mean by fully is no remainders, no decimals, things like that, just a whole amount of times it divides into it. So factors of 6, 1, 2, 3 and 6. Okay, so in other words, what times tables does 6 live in? So it lives in the 1 times table, the 2 times table, the 3 times table, and the 6 times table. That's another good way of thinking about it. So if we wanted to do the factors of 36, then we can do that relatively easily. It's always good to think about factors in pairs. So what I mean by that is, if we said that the easiest factor to start with, this should be something that you should always think of, is 1. 1 goes into anything. So what number must I times by 1 to get 36? Well, that must be 36. So 1 times 36 is 36. So that means that 1 and 36 are factors of 36. If we then go to the next easiest number, notice that 36 is an even number, so that must mean 2 goes into it. So what do I add times 2 by? I.e., what is the pair that goes with 2? That must be 18, because 2 times by 18 is 36. And then we've got 3. What's the factor pair of 3? First of all, it's always good to know that 3 actually does go into 36, but 3 times 12 makes 36. Okay. Then 4 goes with 9. 4 times 9 is 36. 5 doesn't go into 36, and 6 goes into 36 6 times. So you can write 6 and 6, or just leave it as 6, because actually 6 is just the square root of 36. So in other words, it's just times it by itself. Okay, so that's a nice easy way of getting factors. Try and think about them in these factor pairs, the pairs of numbers that go into 36. It kind of helps you eliminate any errors or forgetting any, or not actually figuring them out. So with that being done, that's how we actually find the factors, or what actually factors are. The next step in this is what we call common factors. So what are common factors? Well, I'll show it with an example. If we wanted to find common factors of 15 and 24, what this means is, what are all the factors of 15, what are all the factors of 24, and do they have any in common? I.e., do the factors live in both lists? So if we write down 15, I'll do this quite quickly. 1 and 15, 2 doesn't go, 3 goes with 5, and that's about it really for 15. 24, well, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Notice how I'm doing them in these factor pairs. It makes it nice and easy. 4 times 6 is 24, 3 times 8 is 24, and so on. So with that being said, that is done. So do these lists have anything in common? Well, we've got a 1 in both, and we've got a 3 in both. We don't have a 15 in the list of 24, and we don't have a 5 in the list of 24, so that's pretty much it. So the common factors, or CF, is 1 and 3. And just as a little hint, the highest common factor is the number that is the highest out of this common factor list. So 3 would be the highest common factor, but we'll get to that in a minute. Okay, so that's common factors done. We'll do we'll do one more example actually on that. So let's do some common factors of 36 and 24. Just space these out so I can write the factor pair lists underneath. So 1 and 36, we've already done this one actually. 2 and 18, 3 and 12, 4 and 9, and then we had 6 as well. 24, well, 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's pretty much it. So the common factor list would be the ones that are the same in both. So we've got a 1, 1, a 2, a 2, a 3, a 3, a 4, a 4. So actually they can have quite a lot in common. 6 is in this one, 6 is also in this one, 8 is not, 9 is not, 12 is, 18, 36, 24 are not common factors. So we could write down 1, 2, 3, 4 and 6, oh, and 12, there we go. So 1, 2, 3, 4, 6, 12 are the common factors of 36 and 24. So hopefully that makes a bit of sense and shows you the importance or the usefulness of doing factor pairs. So the next thing we're going to do is prime factorization. Prime factorization. Okay, so what is a prime factorization? Well, hopefully we know a prime number is one which only has two factors, itself and 1. So for instance, 13 is a prime number and it only has 1 and 13 as its factors, so that makes that a prime number. But this is a bit too easy actually. So what the usefulness of prime factorization, if I wanted to express 12 as a product or a multiplication, is the same as product, so a multiplication of prime numbers, I could say that that is like 2 is a prime, times by another 2, which is another prime, times by a 3, which is another prime. So 2 times 2 is 4, and then times by 3 makes 12. So 2 times 2 times 3 is the prime factorization of 12, because we're now expressing 12 as a product or a multiplication of prime numbers that are factors within it. Okay, so there's a real kind of easy way, or a useful way rather, of doing this. So if we have quite large numbers like 252, we can work out a nice easy way of breaking this down into prime factorization without stressing too much. I mean, 12 was really easy to do because it's just small numbers, but 252 is quite a large number, so it's going to have lots of factors presumably. So the way to do it is start with the easiest and smallest prime number that we know, which is 2, and we know that 2 goes into 252 because it's even. So 2 goes into 252 how many times? Well, if you've got a calculator, if you're allowed to use a calculator, you can do that. Otherwise, it's really easy to just do a long division. So 2 into 2 goes once, 2 into 5 goes twice, but with 1 remaining, and 2 into 12 goes 6. So that goes 126 times. So what I've done here is that 252 has 2 as a prime number, but that goes 126 times. So what I'm going to do now is circle this prime number, because I know that it's prime and that cannot be broken down anymore. But 126 is not a prime, so we're going to break this down a bit more into 2 other numbers that go into it, but preferably the smallest prime again. So does 2 go into 126? Well, yes, because it's even. So how many times does 2 go into 126? 63. So what I can do here, say I know that 2 is a prime again, that's why we chose it. It went 63 times. Now, does 63 have any prime numbers that go into it? Or more importantly, what are those prime numbers? Well, clearly 2 cannot go into this anymore because this is an odd number. But does 3 go into it? Well, we can just have a very quick check. 3 into 63. Well, 3 into 6 goes twice, and 3 into 3 goes once, so it goes 21 times. So yes, 3 does go into 63 21 times. So now I'm going to circle this prime, So hopefully you can see what we're up to here. We're just going to continue this. 3 goes into 21 7 times, and actually both the 3 and the 7 are primes. So what I can do is write 252 as a product of its primes is 2 times by 2 times 3 times another 3 times 7. And that is how we do it. In fact, we can make this a bit easier as well. This 2 times 2 is like 2 squared, and then we times it by a 3 times 3, which is like 3 squared, and then we times it by a 7. That's just to kind of neaten it up a bit. And we could do this with any number really. All you need to do is follow this process, circle your, or at least have an idea of how you're going to mark the prime numbers that we've factorized out. And just do that really. Okay, so that is what we call a product of primes, or prime factorization, or prime factor form, or something along those lines. Now, the usefulness of this is to find out highest common factors of quite large numbers. So we've already said the highest common factor, let's just say between 16 and 24. Well, if we were to write down all the factors, we'd find that the highest common factor is 8. Now it does have various other factors as well, like 2 and 4, but 8 is the actual highest common factor. So where are we going with the prime factorization? It can really help us. So what I'm going to do is start an example, and we're going to do it between 120. So I'll just cross this out for now. So 120 and 168. So what I'm going to do is the 120, I'm going to break it down into prime factorization. So that goes 260, 230, 215, and then 3 and 5. Okay, so I've got this 2, 2, 2, 3 and 5. Okay, and then the next one we're going to do is the 168. So I'll do that over here. So that goes 2 and 84. You'll get quicker at this as well. 2 and 42, 2 and 21, 3 and 7. So we've got all of these prime numbers just here that we've factorized out. So how does this help us find the highest common factor between this 120 and 168? Well, if we look at these prime numbers and we create what's known as a Venn diagram, you don't need to know the technical name really, but basically it's just two circles that cross over. And what I'm going to do is say this is 120 and this is 168. So the left hand circle or oval here is the 120, and then the right hand one is 168. But there's this crossover bit, and that crossover bit is where we're going to put the common numbers. So what I'm going to do is I'll start here by saying this is 2, 2, 2, 3 and 5. Okay, and on the right hand one, this 168 was 2, 2, 2, 3 and 7. What we're now going to do is where we've got the same number, I'm going to put it in the middle and cross them off. So there's a 2, and there's another 2, another 2, so I'll put a 2 here, and there's another 2 as well. So we're just putting all of the common numbers from the lists in the box, in the crossover bit. So the 3 goes in there as well, but this 5 is not common with the 168 list, so I'm going to put the 5 outside of that bit. So the crossover bit here is just where the common prime factors live. This 7 will go here because it's not common to this list. And now what we can do is take whatever's in the middle, this crossover bit, and say 2 times 2 times 2 times 3 is the highest common factor. So 2 times 2 is 4, times 2 is 8, times 3 is 24. So the highest common factor between 120 and 168 is 24. Just to recap how we did that, we said 120 and 168, prime factor form for both. Find the lists of these prime factors, and then draw what's this Venn diagram? Two ovals overlapping slightly. The numbers that are common to both lists we put in the middle. The numbers that are uncommon we put on their respective sides. So the 5 goes with the 120, the 7 went with the 168. Any numbers in the middle, multiply them all together, highest common factor. So that is all that you're really going to need to know on number factorization. It does work with algebra factorization as well, but pretty much all we're really looking to do is factor out any numbers that we can from other numbers. And that is it really. If you have a bit of a practice from the CyberTutor online library, and then speak to your teachers if you have any more questions. Laura, so here's a single bracket expansion. Are you happy to give that a go?
Yeah, would it be 6x plus 5?
No, actually, it's not quite that. Not quite right. Do you want to give it another go?
Oh, was it 3 times 5 as well?
Yeah, 3 times 5 as well.
So it'd be 6x plus 15.
Yeah, perfect. Well done. That's good.